Welcome everyone to Microsoft's Build 2017. We're here today to talk about Azure VNet for containers. My name is Narayan Annamalai and this is Mario Lopez. We are both program managers in the Azure networking team. All right, let's get started. We're very excited to talk to you about containers and even more so networking for containers. So let's dive in and see what this is about. So before I talk about containers, I wanted to give a brief introduction about virtual networks, right? So virtual networks is the virtual private cloud for customers when they come to Azure. So this is our network virtualization. You bring your network. Along with it, you bring your policies, your IP addresses, and anything else that you want to bring to this network that you've been probably using on premises or locally at your home. All the networking controls that you're familiar with, you can use the same in Azure using a virtual network. VNet, in a very succinctly, it gives you full control of the network. So you bring the IP address space, you define the policies like DNS, security, and any virtual machine or any workload that you drop into this virtual network automatically becomes private to you, just to you, can be used from others, and they all can talk to one another because they are sharing the same network. And there is a ton of other benefits the networking stack in Azure gives you, like public IPs and load balancing, DNS, traffic management, DDoS protection. So the whole suite of things the software stack, the network software stack gives for you when you use a virtual network. And obviously you can also extend this virtual network and connect that with your on-premises network. It could even be a laptop that you use from home or your corporate servers. You can connect them using multiple different ways that we provide through hybrid networking. And you can just build this virtual private environment for you that extends beyond on-prem as well as to the cloud. Now, the center of all these is SDN. And SDN is software-defined networking. Right. So in the cloud space, we cannot achieve any of these breadth of features if we have to depend on hardware for any of these things. So with SDN, what we do is we use commodity hardware, which is basically routers and switches, and really like a dark fiber that connects these. And the rest of the intelligence, rest of the decision making, all that comes from software. So we have like the software controllers, or what we call them as network agents, sitting on each of our host machines or blades, which can really configure this network for you and make this all come together. So let's look at like what SDN in Azure has done so far, right? So we've been having a very good momentum with SDN. In fact, the virtual network itself was launched only in 2013, but since then we have just added a multitude of other benefits on top of the virtual network. Starting from the load balancing to enhanced security, to reserved IP addresses, to accelerated networking, which really gives you the best performance in the cloud. For a NIC, we have come a long way. Now we are happy to actually extend all of these benefits, the SDN benefits, also to containers. When you run a Docker container in Azure, we want the container to connect to this network that you have already created probably in Azure, and use all the benefits. So what we're really calling this is Azure VNet for containers, right? So with this mechanism, what was available to you in your virtual machines is now available to you also for your containers, right? It's kind of a single SDN stack for whatever that your needs are. So what does it actually mean? This Azure VNet for containers integrates very well with your existing or your open source orchestrators like Kubernetes, Docker, or DCOS from Mesosphere, and it lends networking as a plugin to these orchestrators. We'll see more. So far, what do we have in the world of container networking? So mostly the orchestrators provide a default network connectivity mode, right? That's usually a bridge or a NAT mode, right? What they do with that is they give an IP address per container, but that's only local to that the hosting machine. So within that hosting machine, if they have to talk to some other container, they can just do it. They can have direct communication. But anytime they want to talk to another container that is running in a different host machine, they'll have to go through a NAT bridge. So they usually do a NAT and use a different source port, and then that's how they actually achieve the connectivity. Well, while this works, there are some obvious downsides with NATing. Extra processing, plus the ports are being reserved for a certain container. So if both containers want to talk on port 80 and they both want to go out, and that will be a problem, right? There are other ways to actually work around this, which is you would have seen a lot of people do overlay networking, or they use something like a VXLAN to encapsulate the packet. So they preserve whatever was inside the container IP, and then outside they do another outer encapsulation and use the VM's IP address, because the VM's IP address is routable, or the hosting container host IP address is routable, and then they just use an encap with that. And this works. This will get you connectivity across containers running in different nodes, but doing double encap is obviously a performance hit, and it also takes away from the payload that you can actually send. So there are some obvious disadvantages to this method. So what are we doing is we are providing an easy to use mechanism that works with the existing orchestrators, right? And there are a number of different ways to run containers in Azure. You could just go, take a Linux machine in Azure, build up everything by yourself. You can run Kubernetes, or you can run TCOS by yourself. That is also possible. But a very easy way would be to run it through the Azure Container Service. What the Azure Container Service really does for you is sets up the infrastructure, right? You can go and ask for, I want a master and these many agent nodes, and then set up my orchestration engine on top of these, like Kubernetes, for example. And ACS takes care of all the setup, all the distribution of the files, and everything is good to go. Then you're just left with your familiar ways of just running a container using a kubelet and commandlets from Kubernetes itself. So that is what Azure provides you. What we are now doing with the newer Azure VNet for containers is we are also introducing a virtual network or the Azure SDN stack as a plugin to these orchestrators. So as you're setting up your ACS cluster, as a part of that setup, you also ask for networking to be provided to you through an Azure plugin. And that then automatically hooks up a container to a virtual network. And every container gets a private IP address, and you can leverage the full SDN stack. So we'll see more. So it's currently in a public preview. The solution is in public preview. And what this gives you is full connectivity, like I was saying, because each container that is coming up in this container host is going to have its own private IP address. And this can talk to other containers, or it can talk to even on-premises or other virtual machines. This IP is fully routable because this IP belongs to the virtual network. So there's absolutely no need to do a NAT or no need to do an overlay. It's basically direct connectivity. And because you do this, you can do a lot of other things like connectivity to the on-prem networks, right? And also the load balancing that Azure offers you as a layer 4 and layer 7. You can use either of those to load balance across your containers. And most importantly of all, you have a single unified network policy. So you define that for your virtual network, and that network policy will apply to your VMs as well as containers running on Azure. That's the real benefit here. So very quickly, some of the scenarios I wanted to highlight was, number one was full connectivity within a virtual network. You can talk to VMs in the same VNet, containers in the same VNet, also to peered VNets, maybe containers and peered VNets, all of that would work. You will have full control of your network ACLs. So if you're familiar with network security groups, which is available in Azure for some time now, you could use network security groups to secure the access for containers. You can allow or deny to a specific container. You can do load balancing, which is a great benefit because Azure's load balancer, like I was saying, layer 4 and layer 7 both offer an external load balancer as well as an internal one, right? Public or private IP address. And you can use that, and then on the back end, you can just use containers to do the back end for you. And that's another great benefit. You don't need to have another additional plugin to achieve load balancing across containers. So this works for you. And of course, like I said, once you have these containers, you can talk to on-premises through ExpressRoute or VPN gateways. and just extend this naturally. So if you have containers environment running in your on-premises, another container environment running in your public cloud, they'll have full connectivity if you have linked those networks. That's the benefit. And for ecosystem standpoint, it works on Windows stack as well as in Azure. So that's the thing with on-prem and cloud. It supports all the orchestrators, Kubernetes, DCOS, and Docker. And it's basically connecting the orchestrator on the network. That's really what Azure VNet for containers does for you. The good news is all of it that I was talking about is an open source project. So you can go to GitHub, and that's URL right there, and you can learn about what we have done. We have basically done a network plugin for Kubernetes and other orchestrators, and we also done an IPAM plugin, an IP address management plugin. And both of the code for both of these are open source, and we would love for you to contribute and take advantage of this. Now, enough of the talk. I'm going to turn it over to Mario to see some of it in action. So Mario, you're going to show us a demo today?
Sure, but first let me actually explain a little bit about how this plugin is actually working. The architecture that we have right now, it's actually very nice. It's using actually an open source standard, which is CNI. And with this, you can actually pick and choose whatever components you want and actually integrate this with whatever the needs you have for your container clusters. So this will actually give you the flexibility to choose whatever orchestrators from Kubernetes, DCOS, or Service Fabric. And also, it will give you the ability to actually operate on different operating systems. With this, we are providing a plugin that brings the same SDN capabilities to each of the containers. So basically, each container will have its own private IP. And with this, you will have unleashed all of the powers from Azure SDN, like load balancing, network security, user-defined routes also, and connectivity to on-premises, and of course, the full connectivity to your VNet. Now, this project was integrated with Azure Container Services Engine. It's another open source project from Microsoft, which basically gives you the ability to very flexible create your clusters with the minimum efforts, and you can actually define a cluster with very few parameters, where you can deploy in Azure a whole lot of resources that will actually help you to create a cluster very quick and easy. So speaking of which, we are going to start with the first steps, which is basically create a cluster with ACS Engine, and to see how the CNI plugin is actually integrated with this project. For this one, the first steps that I'm going to show you here, it's the basic configuration file that we have for Azure Container Services Engine. This file actually shows you the way to specify a Kubernetes cluster, which is the one that we are going to use in this demo. And the main config file the main config parameter that we have right here, it's the network policy. Network policy is the one that will actually specify these clusters to use the CNI plugin from Azure. And it will actually give the full connectivity to all of the containers within the same VNet. And here you can also specify the master node and the agent profiles, where you can actually specify the operating system, the size of your VM, how many agents do you want in these clusters, and also some of the credentials that you want to have for this cluster. The access, for example, here's your secure shell credentials, and also service principal credentials. These ones are very specific to container clusters. This one will allow you to actually scale with your clusters and perform additional services on Azure. With these credentials, you are actually providing this cluster the capabilities to scale within the same.
So Mario, here you're saying a user can go download a sample of such a file and start modifying this.
That's right.
This becomes the input to the Azure Container Service itself. And you start with 2 agent nodes, but you're saying it will elastically scale up based on requirements.
That's correct. This cluster, for our demo, we have only a couple of agents, but later on the step, we can actually show you how you can actually scale this to whatever number of agents that you want in this cluster. So it's very easy to actually scale with this. And
here you have picked Azure as the networking plugin. So I assume every container that comes up in this cluster is going to have the Azure SDN stack and the Azure private IP address from the VNet supplied to it.
That's correct. As part of the deployment process, basically, whenever the VM, either the master or any of the agents starts, they will actually consume this CNI plugin, and they will start using as their main network policy provider. So this means that for every new container that you actually start, they will actually use the CNI plugin and provide a new IP addresses for this container.
Right.
So let's go to the actual steps. So the first steps that we have right now, it's basically from ACS. What it does, from this basic configuration, it will create a bunch of templates that you can actually use on Azure to create a new deployment. These templates are a little bit more complex for any user. So basically, within these few steps on the kubernetes.json file, you can actually create a whole new configuration for your clusters without too much complexity for you. And basically, the ACS engine, it's a basic command that you can actually perform with the any command line. What it does, it will create an output folder where you can actually have all of your template files. So all of this complexity for these templates for Azure, it's right away from the customers. They don't actually have to worry about these templates. All they have to worry about is specifying a couple of VMs and the size of the cluster. So using this output as part of our next command line, we can actually deploy a new cluster on Azure. Let me just replace a couple of parameters here and then explain the process. So now, with any interface that you have on Azure Container Services, you can actually use either CLI, PowerShell, or CLI 2.0, which is the one that I'm using right here. You can actually, the first steps, it's to create a resource group. Resource groups on Azure, it's basically a container of all of your deployment where you can actually specify all of your VMs and additional resources will be deployed on this resource group. And within this resource group, now we can actually deploy our new container. So let me actually put this here. What this command actually does, it's create a new deployment where it's basically taking the input files that we have right here, and it's going to create a lot of resources on Azure for these container clusters. Everything is simplified within a couple of steps right here. And this process usually takes between 5 to 10 minutes. It depends on the size of your clusters. But additional to this, you can also scale with additional commands. This is one of the examples where you can actually scale on the same resource group deployment, and you can now define a new agent count for your cluster. So basically, you can create additional agents for your clusters right away. So for this demo, let me actually move to a pre-existing one where we have a cluster already created. So for this one, what it does, the deployment, it's going to create a lot of resources for you. Among them, it's a couple of Linux pool, the NICs for those VMs, the master node, and also network security groups, load balancer for your cluster. All of this, it will be automatically created within this process. Once you have this cluster, you can access them through Secure Shell. And for this, I'm going to show you the basic steps where we actually have, for example, the configuration for this file, which is. So in this file, we actually have within the VM the configuration where we are specifying that we're using the IPAM plugin from or CNI plugin as part of this container. Also, we can show the credentials that we have additional configurations from Kubernetes. In this example, it's basically all of the resource names that we have for our container cluster. Basically has all of the resource group, and additional to that, we have the service principal credentials here that will help this cluster to actually unleash additional features on this cluster. For example, if you want to scale and create containers and expose them, automatically you will get a load balancer for these new services. And now we can use the basic command line to get the nodes, just to have the basics here.
So are you already connected to this master node? This is the master?
This is the master node, and we can actually see here that we have a couple of agent pools here on this master. Mm-hmm. So right now, let's start to use this container clusters, and let's use it to a real example of an Nginx demo, that it's the basic one for containers. Okay, so on this cluster, now we can start new containers. running on this cluster. In this example, we're going to use Nginx to create 3 replicas of the same behavior. Basically, with this one, you will actually get a set of pods that you can actually browse here with this command lines. And what this is actually doing, it's creating 3 pods where you have actually specific private IPs from the Azure VNet containers. These private IPs come from the same VNets. So basically, with these private IPs, you have full connectivity not only within this container cluster, but also to the full VNet and back to on-premises if you have express route or any VPN connection.
Right.
So with this, we can actually expose this service. And for this one, we're going to use another set of commands. So kubelet.
So you
I just exposed the deployment. This is not entirely exposed right now. It's actually exposing internally because right now we have only private IP to access this deployment.
Right.
But we need to expose this publicly. And for that, we're going to consume Azure services to create a load balancer and a public endpoint for this particular deployment.
So what you have is 3 containers or 3 pods running Nginx web content.
That's correct.
You're going to now publish that to the web, so to speak, using the Azure's load balancer and public IP address.
That's correct, but you don't have to actually know all the details from Azure. Basically, it's already integrated within the cluster. All you have to do is just expose this, and basically will interact within Azure, making some RESTful calls, and you will get all of this behavior basically here.
So expose is doing that for you. Got it.
That's correct. So all we have to do is basically this deployment, we're going to change between cluster IP to load balancer. What this will actually do is that it will actually consume services within Azure. And right now, as you can see, it's pending, asking for an external IP. Underneath, this process takes about 3 minutes to actually request this to Azure and create a load balancer, and everything will be working on the port 80 for all of these services. So basically, you will get a new private public IP and accessible in port 80 with running these services.
I see.
And within this, we can actually curl the private IP right now, because this process takes about 3 minutes. But internally, we can see that we have already our welcome Nginx here within the private IP.
Got it.
But now we can test a little bit of connectivity between while we were waiting for the external IP. So let's start with the pods that we have. So we know that we have 3 pods right here. The first 2 are running on the first Linux agent pool, and the third one it's on a different one. We can
so these are 2 different container hosts. The first container host, which is the Linux VM, is hosting 2 containers, and the third one is hosting 1 other container. So you're going to try and talk between the containers now in different nodes?
That's correct.
Okay.
Within this container, you can actually prove full connectivity not only within the containers, but also to the same VM, to the whole container cluster, and also different VMs within the same VNet. For this example, we can actually ping for example, 240.0.148.
So 248?
I'm sorry, 148. So this is a different container using a different private IP within the same VNet. In this particular case, it's within the same agent pool.
Right.
But we can also ping the other one, 31, I think. So it's showing full connectivity to different containers on different pools. We can also ping additional VMs that we already pre-deploy here.
On the same virtual network.
On the same virtual network. And this actually proves that you can actually ping a different VM within the same VNet.
This is all, so we're not using any overlay, no NAT mode, it's just direct straight connections in the virtual network.
That's right. Containers are considered right now first level citizen class on the network. They are basically the same behavior as another VM. They don't have any different from network perspective. We can also show from this container the IP address that we have, just to confirm, and we can also modify the behavior from this container. As you can see, we also have Nginx running on the different pods, but all of them have the same welcome Nginx. What if we want to actually show different views for this one? We can actually show what the output for this VM looks like for this pod, and we can see that we can modify this file. Let's actually make some move here to modify this behavior. So I'm going to replace this index with another content so that it has actually the private IP for each container. I'm going to do this for a couple of the pods, and then we can actually start looking at different outputs on the load balancer.
Wow.
So let's make the same for additional the third pod. I'm going to actually make the same behavior. So for the third pod, which is in a different agent pool, I'm going to make basically the same behavior. Okay, so now we're ready. Now we know that we can actually curl these services, and we know that each pod will have different content. Two of them will have the private IP on it, and one of them will have the welcome to Nginx basic one. So let's see if we have already deployed the service on Azure. As you can see now, we have a public IP.
Wow.
What it actually did, it's basically went to all the way to Azure and asked for all of these resources. And right now we have another load balancer here placed for this particular service on port 80. So basically you now have this service running here on this container cluster. And within this public IP, you can now curl this public IP, and basically you will have access to different containers within this cluster, which are perfectly load balanced by Azure. And as you can see here, we have a different output for different purposes. We can see that some of those has the welcome to Nginx, some of those has his own private IP. And what happens if we actually kill some of these containers? You can actually delete one of these deployments, one of these containers. For example, let me use the, let me actually go to the first one, and now let's try to see what the heal process from Kubernetes actually does here if I try to delete this specific container, which actually has some specific private IP on it. So this process will actually try to terminate this cluster, but within this load balancer, you will no longer have any problem because actually your services will be load balanced with additional containers. So you will have highly available container clusters running, and you don't have to worry about each one of these containers are actually turning down for whatever reasons. You have this connectivity back to whatever other container you have running there.
And all using Azure's load balancers and Azure's virtual network.
That's correct. Now I'm going to show you the network security group. How do you actually ping the different VMs on the same network? Right now I have a pre-configured NSG here that actually has a network security rule that it's blocking my access to one particular VM within the same network. So you can actually define different set of rules with network security groups. I'm not going to cover this in detail, but you can actually remove some of these rules, for example, just to show that this connectivity, it's controlled right now by the same SDN stack on Azure. And you don't have to actually have double layers of management. You don't have to worry about having double firewall technologies on your container clusters.
So you could have rules over here that target only a specific container.
That's correct.
So you can allow and deny specific rules.
And as you can see right now, I removed my deny rule, and now the traffic is coming out.
Oh, perfect. That's great.
Yeah. Okay. So coming back to the presentation. So this is basically the demo. we actually make a load balancer and network security groups apply to the same container cluster. We
Perfect.
prove the connectivity between containers on the same agent pool, on different agent pools, and also connectivity to within the same VNet, and also load balancer, network security groups, the same SDN stack available for you for containers. So right now you have basically all of these capabilities from Azure that were available to VMs. It's now available to containers. The same connectivity to on-premises, the same connectivity to VMs. You can actually perform the same on containers within the best performance that you can have. And now it's fully integrated with the ACS engine, which it's very simple to use. It's very easy to actually deploy clusters and have these capabilities from Azure without any extra management efforts.
Cool. And yeah, those are the references. I hope we had great fun watching this session from us. And if you need to know more, here are the references. You can look at them. Definitely play with it and send us your feedback. Thank you.